Hey there, and welcome. If you look at the world of modern design, it's filled with these incredible, almost alien-looking forms. We're talking about buildings that flow like liquid and products that seem like they were grown, not built. It kind of makes you wonder, how on earth did we get here? Okay, let's get into it. I mean, seriously, how do you even begin to dream up something like Frank Gehry's Guggenheim in Bilbao, with its shimmering, flowing metal? Or the Yokohama Port Terminal, which is just this one continuous, mind-bending surface. These things don't feel like they were just sketched out on a piece of paper. They feel like they were discovered. So what changed? What was the big shift? Well, the answer really boils down to a fundamental change in logic. For centuries, our world was built on an industrial age idea. Standardization. You make one perfect brick, and then you make a million more exactly like it. But then the digital age came along and introduced a totally new logic, the logic of differentiation, where every single piece, every component can be totally unique. To really get this revolution, we need to follow the evolution of the design process itself. You know, how we went from the straightforward, simple logic of a blueprint to the complex, organic, and sometimes just plain weird forms we now call blobs. Just think about it for a second. The entire modern era was powered by the module, the idea that you could build something massive and complex just by repeating a simple, standard part over and over again. And that way of thinking was a perfect match for paper blueprints in the assembly line. It was efficient, it was predictable, and it was super orderly. Okay, so this diagram here, this is kind of like our map for understanding any design process ever. At its heart, you've always got these four parts. You have representation, which is the drawing, generation, the ideas, evaluation, judging if those ideas are any good, and performance, how it all actually works in the real world. The whole story of the digital revolution is about how the connections between these four things got completely rewired. And to follow that story, we need a key. It's pretty simple. On the diagrams we're about to look at, if you see a dotted line, it means that process is implicit. It's all happening inside the designer's head, in their intuition. But if you see a solid line, that means the process is explicit. It's a formal, computational thing happening inside a computer. And trust me, that distinction is everything. So this is our starting point, the good old-fashioned, paper-based way of doing things. The designer is looking at the representation, the drawing on the paper. But everything else, the generation of ideas, the evaluation of them, thinking about performance, that's all happening inside their brain. The designer is the CPU here. See all those dotted lines? It's all implicit, all cognitive. Right, so this model, where the designer's mind has to do all that heavy lifting, is the very bedrock of that old logic of repetition. It worked great for a world of standardized parts, but it definitely has its limits. So the question is, how did we break free? Well, that escape didn't just happen overnight. It was a gradual process, and we can actually track it through 5 distinct models of digital design. Each one builds on the last, and with each step, more and more of the design process gets pulled out of the designer's head and handed over to the explicit power of the machine. We're going to walk through this whole evolution, starting with basic CAD models. Then we'll get into the really cool stuff with formation models, where form literally starts to emerge from a digital space. After that, we'll look at generative models, where the designer creates the rules, not the object. Then performance models, where real-world data starts to do the sculpting. And finally, we'll see it all come together in the compound model. Each step here is a massive leap forward. So step 1 was computer-aided design, or CAD, and this was way more than just drawing on a screen. The really crucial thing here is that for the very first time, the evaluation process became explicit. You see that solid line right there? The computer could now be linked directly to the digital drawing to automatically analyze things like cost, or materials, or structural stress. You've got a feedback loop now, but the designer is still the one manually drawing the form. Okay, now this is where things start to get really wild. With formation models, the whole idea of representation begins to break down. You're not just drawing a shape anymore. Instead, the designer is interacting with a digital environment, a whole set of rules and forces, and the form just sort of emerges from that interaction. You're not making the form, you're finding it. And this can happen in a few different ways. Topological models are what gave us that blob architecture look because they focus on fluid relationships instead of fixed points. Then you have associative or parametric models, like for the Waterloo Terminal, that use rules to link everything together. So if you change one part, the whole thing intelligently updates. And then there are motion-based models, which use animation tools and simulated forces to literally sculpt with movement. And that leads us to the next level, generative models. Here, the designer takes another huge step back. Now they're not interacting with the form or even the digital environment. They are designing the generative mechanism itself, the actual algorithm, the shape grammar, the evolutionary system that will then go off on its own and produce thousands of design variations. And this just illustrates the whole journey perfectly. I mean, look at this. On the left, you've got the old paper model, where almost everything is just a thought process. And on the right, you have a performance-based generative model where generation and performance are these explicit, powerful digital systems, all interconnected. It's a completely different universe of creating. This brings us to performance models. This is where the form isn't just evaluated after it's designed, it's actively shaped by performance data from the very start. The perfect example is the Swiss RE Tower in London. Its iconic aerodynamic shape wasn't some aesthetic choice. It was literally generated by complex simulations of wind patterns around the building to make it more energy efficient. The performance data created the form. So, as we move through these models, something really profound starts to become clear. This isn't just about getting better software. The evolution of these tools has actually forged an entirely new philosophy of design, a whole new way of thinking about what it even means to create something. And this quote from Rivka Oxman, whose work we're exploring here, just nails it. We've moved beyond the idea that design is just about making static pictures of things. The design process itself has become dynamic. It's become interactive. And in a way, it's become intelligent. And what this does is fundamentally change the role of the designer. They're not just people who use off-the-shelf software anymore. To really work on the cutting edge, they have to become toolmakers. They have to script their own custom processes and build the very generative systems that are going to produce the final design. So what does this new mindset really look like? Well, for one, it's non-deterministic. It embraces unpredictable, emergent results. It's also non-typological, which is a fancy way of saying it prefers unique outcomes over just repeating standard types. It's performative, meaning real-world data is a core part of finding the form. And finally, it's morphogenetic. It is obsessed with the process of how a form comes to be, not just the final static object. This whole evolution, this new way of thinking, it's all pointing toward a future where our ability to design and manage incredibly complex systems is reaching a whole new plane. And that brings us to the final and maybe most advanced vision for this whole process. This is the compound model. You can think of it as the ultimate goal, the holy grail. It's a fully integrated, intelligent network where every single part we've talked about, generation, representation, evaluation, and performance, is an explicit process, constantly talking to and influencing all the others. The designer can step in and interact with any part of this seamless system. It's a true dialogue between human intent and massive computational power. And that leaves us with a huge final question. This was never just about making cool-looking buildings. This is a new way of thinking, a new way of solving problems by embracing complexity, performance, and emergence. So if our design tools can operate with this level of intelligence, how is that going to change the way we design our cities, our products, maybe even our social systems? What on earth are we going to create next?